There was something sitting on Sandy Munro's desk, and the legendary automotive engineer just could not stop looking at it. Munro is notoriously difficult to impress. He has spent his entire career tearing apart vehicles from the biggest automakers on the planet, stripping away every bolt, weighing every single panel, and bluntly exposing what works and what is a complete waste of money. He has never been afraid to look Tesla engineers in the eye and tell them a component looked like it was designed by a child. But when he cut open this specific drive unit, everything changed. What was wrapped around the rotating core wasn't standard industrial metal. It was carbon fiber, tightly wound and heat-treated to an extreme degree that Munro could only describe as genuinely scary. This wasn't just a motor. It was a physical impossibility that broke the unwritten laws the automotive industry had obediently followed for decades. Tesla had quietly engineered a machine that accelerates faster than hypercars costing millions, operates with terrifying efficiency, and is so incredibly complex to manufacture that competitors might need a decade just to catch up. To understand why this single piece of hardware sent shockwaves through boardroom tables from Detroit to Stuttgart, you have to look at the massive compromise engineers used to accept as gospel. For years, building an electric motor was a game of sacrifices. You could make a vehicle incredibly powerful, but it would become massive, overheat rapidly, and drain the battery. Or you could build it for extreme efficiency, leaving the driver with a painfully boring, slow commute. Tesla completely rejected that compromise. Deep inside their newest drive units, they perfected a carbon fiber-wrapped rotor. When an electric motor spins at high velocities, the intense centrifugal forces literally try to tear the metal apart from the inside. Tesla solved this by wrapping the rotor in aerospace-grade carbon armor, holding the core together under completely violent pressure. This allows the drive unit to spin at an astonishing 20,000 revolutions per minute, speeds usually reserved for industrial turbines, not the family sedan sitting in your driveway. The carbon wrapping stabilizes the magnetic performance, meaning less battery power is wasted as heat, and more is converted into pure, instant torque. But the true nightmare for rival CEOs wasn't the speed itself. It was the realization of what happens next. The nightmare deepens when you step off the factory floor and look closely at the chemical foundation of the battery cells themselves. For years, almost every major manufacturer on Earth has relied on a process called wet electrode coating. It requires dissolving active battery materials into a highly toxic liquid solvent, coating it onto metal foils, and dragging it through massive industrial drying ovens longer than a city block at 150 degrees Celsius. But as the liquid evaporates, it pulls the binding polymers to the surface in a phenomenon called binder migration. This creates microscopic structural cracks inside the battery from the very first day it rolls off the line. Tesla realized this was an unacceptable flaw and completely rewrote the chemistry book. They engineered a second-generation dry electrode process using Teflon polymers. Inside a supersonic air-jet milling chamber, compressed air stretches the polymer into microscopic fibers that physically weave the battery materials together like an unbreakable net. No toxic solvents. No massive drying ovens. This single leap eliminates 70% of the mechanical processing stages, saving enough electricity to power the entire New York City subway system for 5 years. But even with the perfect battery, the materials powering the motor were hiding a massive geopolitical threat. Every traditional high-performance electric motor relies heavily on rare earth neodymium magnets. The problem isn't that they are rare. It's that the mining and refining of these materials are overwhelmingly controlled by a single global superpower. By relying on neodymium, automakers were essentially routing their entire production output through a foreign supply chain that could be weaponized and shut down by a single political embargo. Tesla recognized this fatal vulnerability and completely changed the magnetic architecture of their next-generation motors. They shifted their focus to ceramic magnets and iron oxide, materials that are cheap, abundant, and completely free from foreign export chokeholds. By redesigning the cooling systems, the software controls, and the rotor shape, Tesla managed to extract immense, reliable power from ordinary, easily accessible materials. They successfully engineered a permanent escape route from a supply chain trap that still has legacy automakers completely paralyzed by fear. And what happened next would shock everyone waiting for affordable transportation. Imagine waking up in the near future and walking into a showroom to buy a brand new technologically unmatched electric vehicle for just $11,990. While legacy automakers are desperately trying to convince buyers to take out massive loans for bloated $40,000 sedans, Tesla has been quietly running heavily camouflaged prototypes of the rumored Model 2 along California highways. The secret to this shocking price tag isn't stripping away features. It is an entirely new manufacturing philosophy called the unboxed process. Instead of welding 70 individual stamped metal panels together, massive 9,000-ton casting machines press aerospace-grade aluminum into a single, seamless structure. Each casting cycle takes barely 90 seconds. The structural battery pack becomes a load-bearing floor, creating a chassis with a torsional rigidity 30% higher than the Model 3. It absorbs crash forces like a fighter jet handling high-speed maneuvers. You are looking at a vehicle that costs less than a used compact car but is structurally reinforced to survive 20 years on the road without a single rattling panel. But a bulletproof chassis means nothing if the software driving it makes you terrified to take your hands off the wheel. For years, one of the darkest shadows hanging over Tesla's reputation was the terrifying phenomenon of phantom braking. Moments where the vehicle would violently slam on the brakes for absolutely no reason at highway speeds. It shattered consumer trust and gave critics endless ammunition. The upcoming architecture completely neutralizes this ghost in the machine. Armed with FSD-supervised version 14, the vehicle utilizes a neural network trained on millions of miles of real-world driving data. It integrates 12 high-resolution cameras, upgraded millimeter-wave radar, and for the first time, a short-range LiDAR sensor mounted directly into the front bumper. This three-layer cross-checking system flawlessly predicts the movements of surrounding traffic and pedestrians, reportedly eliminating false braking incidents entirely during intense internal testing. But the safety overhaul didn't stop at the software. Addressing quiet but horrifying reports of occupants getting trapped inside cars during power failures, Tesla engineered a hidden, mechanical stainless steel release inside the door trim. It requires zero electricity and less than 5 kilograms of force to open, ensuring that anyone, regardless of age, can escape a compromised vehicle in under 3 seconds. But the true longevity of this machine was hiding right beneath the floorboards. The final breakthrough currently keeping the entire global automotive industry awake at night is the perfection of the immortal battery. Traditional lithium-ion cells naturally begin to degrade after a couple of thousand charging cycles, meaning early adopters eventually face massive, unavoidable replacement costs. Tesla's research and development teams are actively pushing sodium-ion and aluminum-ion battery chemistries to commercial scale. By utilizing a salt-based ionic gel electrolyte that refuses to evaporate, chemical stability skyrockets. We are looking at batteries projected to easily withstand up to 10,000 full charging cycles while losing less than 10% of their total capacity. If you drive an average of 12,000 miles a year, this battery architecture could theoretically last for over half a century. You could pass this vehicle down to your grandchildren, and it would still hold 70% of its original charge. Tesla is not building a car designed to quietly die after a decade of planned obsolescence. They are engineering a machine that is fundamentally designed to outlive the person who bought it. And while Tesla scales this immortality, the rest of the industry is drowning. Take a hard look at the current automotive battlefield, and the reality is nothing short of a financial bloodbath. Ford has built genuinely incredible machines like the F-150 Lightning, yet they are hemorrhaging over $1 billion a quarter in their electric division. Rivian is losing tens of thousands of dollars on every single truck that rolls off their line. Even massive giants like General Motors and Volkswagen are utterly bogged down by software failures, delayed rollouts, and exploding production costs. Why? Because they are still trying to play by the old rules. Tesla isn't just selling cars. They are monetizing an entire, inescapable ecosystem. Every time a Ford or GM owner plugs into a Tesla supercharger, Elon Musk collects a toll. Every mile driven feeds massive amounts of raw, invaluable data back into Dojo, Tesla's proprietary supercomputer, constantly training the artificial intelligence that will dictate the future of autonomous travel. Competitors are renting cloud space and begging third-party suppliers for batteries, while Tesla owns the chips, the software, the charging grid, and the raw manufacturing blueprint. We are standing on the edge of a massive, irreversible shift in how human beings interact with transportation. Tesla has successfully taken the electric motor, a concept born in the 19th century, and weaponized it with aerospace materials, artificial intelligence, and a manufacturing process that bends the laws of traditional economics. But this ultimate technological supremacy comes with a heavy, unspoken cost. As the vehicles become increasingly self-diagnosing and perfectly integrated, they also become a completely closed ecosystem. You are trading the traditional mechanical freedom of repairing a car in your own garage for a futuristic machine that updates itself while you sleep, runs on an immortal battery, and completely locks you into the manufacturer's exclusive network. The era of the simple mechanical automobile is dead, and the era of the self-aware driving supercomputer has officially begun.